What's up YouTube? My name is Ali and welcome to my first YouTube video. I'm an undergraduate student studying electronic engineering. Wow, I can't talk. And I just love security. So this first video is going to be the first part of a few videos doing write-ups on the picoCTF 2019 Capture the Flag Challenge. Or competition, and in this first video we're going to be looking at some of the binary exploitation challenges. Please note, I'm not an expert at this at all. I'm merely a novice, but if you could support the channel by subscribing, leaving a like and a comment, leave your feedback, I would greatly appreciate that. So let's jump right in. So I've got my terminal here. I've got a few of the challenges set up. I'm just going to try and do as many as I can in about 10-15 minutes. So we'll start with practice run 1. This is the first challenge. Now if we go to the picoCTF website, it can be found here. It's always accessible. You can do the challenges whenever you want. So there's just the program here. You can download that. I've already got it here, so we're going to make it executable by using the change mode command. Make it executable with the +x, and the file name is run this. So now we can execute it by doing /run this. And that just gives us the flag straight away. So you can take that and copy and paste it straight in and submit that. And if you didn't know, on most Linux environments, if you highlight text you can then just middle click it. So on a laptop that's like 3-finger click or click in the middle, but with a mouse you click the scroll wheel. So that was our first challenge, worth 50 points. The second challenge we're going to do is handy shellcode. So we've just finished our first challenge, practice run number 1. So now we're going to start handy shellcode, which is the second challenge in the picoCTF binary exploitation. I say second, but it's kind of the first. It's just practice run is a lot easier and has more solves, so kind of seems fitting to put it first. So we're going to go into handy shellcode. The program can be downloaded there along with the source code, but I've already got it downloaded. Sorry, I've just recorded and failed, so this is my second attempt here. So we're going to just run the vulnerable program, and we can see that it takes our input, echoes it, and then it crashes. And if we have a quick look at the source, we can see, well, it takes our input, echoes it back to us with puts, and then you've got this funny line here. So what this actually does is, the first part of it here, this takes buff and it casts it to the type function pointer of a void, so it returns nothing. And then the pair of parentheses at the end tells the compiler to execute it. So it'll basically go to the address of buffer and execute whatever is there. So we can abuse this by injecting shellcode. And if you don't know what shellcode is, it's basically raw assembly or machine code that the CPU will interpret. So if we go to a website called Shellstorm, they have loads of beautiful shellcode examples that you can just use. The one I'm going to be using is this one here. It will execute execv with bin sh, so it'll get us a shell, and so firstly I'm gonna take this, I'm gonna echo it with escape characters, and so line number 1, if I tried to paste this all on 1, it would be a bit messed up. So you've got to copy each line. Sorry for my bad voice, by the way, I'm literally just recovering from a nasty cold. And we're going to pipe this into a file called in.txt. Now we can cat this file, and you can see it's got nice string bin sh, but it's also got a few other weird characters which we can't read. But that's not the point of this. What we're going to do is try debugging the program, see what happens. So we're going to GDB, which is a GNU debugger, and we're going to give it the vulnerable program. So now we're going to run, we're going to give it our input in.txt, and we can see process is now executing a new program, user bin dash. So if we have a look at file / user bin dash, well, we wanted it to execute bin sh. So if we have a look at / bin sh, it's a symbolic link to dash. So we have successfully managed to execute bin sh. So what we can now do is we can cat our input file and pipe it to our vulnerable function program. And that's weird. It didn't crash, but it didn't give us a shell. So this is actually, you'll probably scratch your head for a long time trying to do this, but if you just call cat on its own, it'll just echo your input to you. But what's happening is we're calling the program cat, and it's then passing what its output is to vuln. But then once it's done doing that, it just exits. So what we actually have to do is cat our in file, then we execute another instance of cat, which will take our input and pipe it to vuln, and it'll keep going. See, because this didn't close automatically, I had to exit it. So if we now put that into vuln, and we can see that that worked. So we've got our successful exploit. Now if we go back here, we have to go to the shell server. So we can go sh at shell1.picoCTF.com. Nope, it's 2019, my bad. They changed the servers quite a lot, so we're just gonna do that. And now we can re-authenticate. I'm gonna log in. And now we're gonna go to that directory. Nope. Paste. There we go. So if we have a look in here, we can... Oh, there's the flag. Cat flag? No. So the flag is owned by Handy Shellcode 3, and you can see it's got the S bit, which is sticky. So it's going to execute as Handy Shellcode 3, and when we get our flag, then, or when we get our shell, that'll be able to read the flag. So I'm just going to open another tab, and we're going to do cat our in file, and we're going to encode it in base 64 just so that we can copy it really easily. And we're going to say no new lines, so we can take that. That's now in our middle clipboard. We can now go echo u into base 64 minus decode. We're going to also cat, as we did earlier, and then we're going to pipe that into vuln. And as you can see, we do ID, and our group ID is handy shellcode 3. Nice. So now we can go cat's flag. Oh, don't have autocomplete, so flag.text, and there's our flag. So we can take that and we can submit it, and that's the second challenge done. So we're, I think, about 10 minutes in now. Let's just try and do the first overflow, because that is super duper easy. So we're gonna go here and we're gonna go into overflow 0. So as always, you can download the program and the source. I have already done this. So we can go, yeah, I can't type. Sorry for background noise, I have flatmates. So now we can execute vuln, and oh, flag file is missing. So what we're just going to do is touch flag.text, and oh, okay, no flag.text. That's normally what I just do to have a simple flag so I know when I get it right. So now we're going to try that again. Execute vuln, please enter an argument next time. So now we're just going to spam with a load of A's. Okay, nothing bad happened. What happens if we give it a few more A's? Oh, so it literally just gave us a flag. So that's so easy, we're just going to, nope. So by the way, I already have the path for the shell server. So what I can do is, no, did it actually save it? Yeah, it did, okay. So I'm now in overflow 0, and as you can see, we've got the flag and we've got vuln. I can't execute, or can't get flag because it's owned by overflow 0, but again, it has the sticky bit set. So we're going to execute vuln, and we're just going to pass it a load of A's, and there we go, easy peasy. You can take that and copy it into and submit. We're 12 minutes in, so we're going to try and do one more. Here we have overflow 1, which is worth 150 points now. We're going to go back in here, and we're going to go into overflow 1. As always, you can download the program and the source, but I already have that, so I'm going to make vuln executable. Oh my god. And oh, so this gives us a bit more information. So what we can do is we can give it a load more A's. Oh, so if you're not familiar with ASCII, the capital letter A is represented by hex 41. So what just happened was we overwrote the instruction pointer somehow or other. So we're going to try vuln again. Nope. But we're just going to not give it as many A's because we know that that worked last time. Okay, that wasn't enough A's. So this is just the process of narrowing down how many A's you want. Ah, so we're at the perfect number now. But you can see the full one's there. Why isn't the full one over here? So processors work with what is called little endian. So the first byte is the lowest and the last byte is the highest. So it's basically backwards of how we would do numbers. So what I'm going to do now is start debugging Vuln. So we know that we have the right number of A's, because, well, there's your A. So now what we need to do is have a look at the source code. So, there's a function called flag. Let's have a look at this. It opens the flag file, and if there's no flag, blah blah blah, otherwise it prints the flag. That's what we want. So what we're going to do is we're going to find the address of flag. So we're going to X for examine and the symbol flag. So you can see it's there. So what we can actually do is, oh, I'm sorry. So we've got the right number of A's somewhere up here. So that's one too many A's. Echo tacky, and that's one too many A's. And we're going to put that into in.text. Then we're going to take this address here, and we're going to start adding it. So E6. Now if we were to do /vuln, cat in.text and pipe that into Vuln, we can see that the last byte has now been changed to E6. So the next byte we need is 85. So let's add that now. So we do slash as the escape character, X for hexadecimal, and we add the 85. So now if we run that, whoa, we've now got 80085E6. And if we have a look at our hexadecimal here, that's very close to what we want. We want 80485E6. So we only actually have to add one more byte, and that's the 04. So now if we run this, so we've jumped to 485E6. So that didn't quite do what we want, but if we add the 08 to it, and now run it, flag file is missing. So we know that we've now jumped to the flag function that we saw earlier, and we can try this on our on the shell server. So we're going to copy the path, we're going to cd into the path, so overflow 1, and now we're going to cat our input file into base 64 with no new lines, just a lot of A's. And now we're going to go echo U into base 64 minus decode, pipe that into Vuln, and as you can see, we got the flag. So now we're changing the return value, and we can go over to picoCTF and we can submit this, and that's the flag. This is the end of my first video. I hope you enjoyed it. I will be hopefully releasing some more videos on all of the other challenges I solved, which in the grand scheme of things is not that many, but I did 62 in total. I'm pretty impressed with my score. It's about a third of the full score. Sorry if this video was a bit long, but I hope you enjoyed. Please like, share if you want to, subscribe, leave a comment, leave me feedback on how I can improve, things to do, and I look forward to seeing you soon.